All right, numbers 7 through 13. Here we go. Okay, number 7, since it didn't print very well on my paper, it's very difficult for me to explain this one for you. So I'm just giving you the answer. It's 100. Okay. Basically, in the last step, you have something like 63 plus 36, and that ends up being 100. It's by factoring, which we did not learn. So that is why. Good job. Okay, number 8 says write the prime factorization of 1,350. Someone I was helping them figure it out, and I was accidentally writing it on my paper, not theirs. And so that's why it's on this one. And you guys saw some of it. So here we go. Prime factorization. What you do is you break the number down into only primes. So this is where we make this cool tree looking thing. So what is a number I can divide 1,350 by? 10. And I know that because it ends in a 0. When I divide that by 10, I get 135. Are either of these numbers prime? No. So I need to keep going. Okay. What can I divide 10 by? 5. When I divide 10 by 5, what do I get? 2. Okay, now we check. Is 5 prime? Yes, so I'm going to circle it. Is 2 prime? Yes, so I'm going to circle it. So I'm done with that branch of my tree. Okay, so now I'm going to do 135 is not prime, so I need to break it down. What do I break it down into? Okay, I can divide it by 5. Is 5 prime? Yes, so I circle it. What do I get when I divide 135 by 5? 27. Okay, is 27 prime? No, it is not. What can I divide it by? I can divide it by 9. Is 9 prime? No. What do I get when I divide 27 by 9? Is 3 prime? Yes, circle it. Okay, time to break down 9. What can I divide 9 by? 3. 3, is that prime? Yes. And what do I get when I divide 9 by 3? 3. Okay, so we made our fancy cool tree. That is not the final answer. So now nope, that's the whole answer right there. Okay, from here, the way we write out our answer is from numbers from least to greatest. So what is the smallest prime? 2. And there's only one of them, so we'll say 2 times, what's the next number? And how many of them are there? There's 3. So I would write 3 times 3 times 3, or 3 to the power of 3 times, what's the next number? How many of them are there? To the power of 2. Okay, we should all have that written down. So I should see a tree on everybody's paper. That looks just like that. All right, so there's that. What? Do we get the answer for number 9?
Like how we did it for number 7.
For number 9 or for number 8?
For number 9.
No, number 9 we should technically be able to do, but it is a lot of work. Okay, so here we go. We have a horse that gallops at a speed of 44 feet per second. What is the speed of the horse in miles per hour? Okay, so we have feet per second. We want it to be miles per hour. So we are going to say 44 feet for every one what? Second. Okay, we don't want it in feet per second. So we're going to multiply this by a conversion factor where we get rid of the feet and instead we have miles. Okay. Then we look at our conversion chart on Big Ideas, or on Google Classroom, I should say. We will see that 1 mile is equal to 5,280 feet. Okay, so this is great. What happens to the feet? They cancel out, and I end up with an answer that is in miles per second. Do I want that? No, I want miles per hour. So I'm going to multiply this by a conversion factor, and I need to get rid of my seconds. So a second's going to go on top or bottom? Top, because right now it's on bottom, and I want it instead in hours. So anyone know how many seconds are in 1 hour? 3,600, right? 60 seconds per minute, 60 minutes per hour. You multiply those two and you get 3,600. Okay, at this point, I should have said that calculators were okay, but the assignment does actually say calculators are not okay. So now we see that our seconds cancel, and then we're going to break the rules and use a calculator. So we're going to multiply across up here and then divide by this. So what is 44 times 1 times 3,600? Exactly, okay? 44 times 1 times 3,600 is 158,400. Come on, guys. You should have done that. All right, this one should be easy. 1 times 5,280 times 1. Yeah, 5,280. So now we'll divide these. Obviously, we can do this by hand. It's no problem. And then when we do that really quick in our heads, because we can just do that in our heads, we get, I'm using a calculator, we get 30 miles per hour. All right, number 10. Jeez. Okay. We need a second more to write this down. Are we ready for number 10? Ready for number 10? Okay, where did my assignment go? Uh-oh. Okay, number 10, again, got printed weird on my paper, so that's not super helpful. So, okay, so the question says, which equation correctly demonstrates the distributive property? So the distributive property is where we have a number out. Oh, I'll wait until I have your attention. Okay, is when we have a number outside of parentheses with numbers being added or subtracted inside of the parentheses. Okay, then what do we do? Delaney? Nope. Distributive property, Michaela? We multiply A by B and A by C. Okay, so what's A times B? AB. Plus, what's A times C? AC. And which one is that? Isn't it like the first one? Oh, G. It's the second one. All right, number 11. Which number is equivalent to 2 4/3 times 1 2/7? Okay, what are we going to do for this one? Hey, Jacob, I'm going to have you take the headphones out. I want you paying attention, please. Okay, thanks. All right, so we're going to do around the world to turn these into improper fractions. What is 5 times 2? Plus 4? 14 over 5. Times, what's 7 times 1? Plus 2? 9 over 7. Okay, then what's my next step? Cross cancel. Check for cross canceling. Is there any?
14.
Yeah, 7 and 14 can both be divided by? They can both be divided by 7. What's 14 divided by 7? 7 divided by 7. Okay, what about 9 and 5? No, they don't have anything in common. Okay, so 2 times 9 equals? What? 18? You got it backwards. It's okay. All right, 5 times 1? Okay, can I leave it like that? No, this is improper. How many times can we take 5 out of 18? 3 times. Okay, when we take 3 sets of 5 out, how much is that? 15. We took 15 out of 18. How much is left? 3 is left, and then we always keep our denominator the same. All right, number 12 says, which pair of numbers does not have a least common multiple of 24? It would have been helpful if I had printed those numbers. So we have 2 and 12. We want to know which ones have a least common multiple that is not 24. So 2 and 12, my piece of advice for finding least common multiple, start with your biggest number, list off multiples, and then see if they work. So let's list off the multiples of 12. First we have 12. Does 2 go into 12? Yes, so their least common multiple is 12. It said which one does not have a least common multiple of 24? That was quick. It's that one. Okay, so the answer is F. But we will check the other ones just in case. 3 and 8. So I'm going to list off my multiples of 8. So we start with 8. Does 3 go into 8? No. Does so then next is 16. Does 3 go into 16? No. So next is 24. Does 3 go into 24? Yes. Okay. Then we have 6 and 8. So I already listed off some multiples of 8. Can 6 go into 8? No. Can 6 go into 16? No. Can 6 go into 24? Yes. So their least common multiple is 24. Then we have 12 and 24. So we list off our multiples of 24. Start with 24. Does 12 go into 24? Yes. So their least common multiple is 24, which is why the only answer was F. Okay, and finally, number 13. Which number is not a perfect square? So a perfect square is the product of two of the same numbers. Okay, so what's the very first perfect square?
100.
No, just in general, what's our very first perfect square? 1. Because 1 times 1 equals?
1.
Okay, then what? 2 times 2 is?
4.
4. 3 times 3 is? 9. 4 times 4? 16. 5 times 5? 25. 6 times 6? 7 times 7? 8 times 8? Oh, 64. That's a perfect square. It says which one's not a perfect square, so I cross out 64. Okay, we just did 8 times 8. 9 times 9? Okay, so we cross out 81. 10 times 10? 100. Okay, could 96 possibly be a perfect square? No, it can't, because we went from 81 to 100 and we didn't see it, okay? It does not necessarily mean that it's prime, but it does mean that it's not a perfect square, okay? All right, so make sure you have all of your work done for all of those and go ahead and turn it into the box.